Yes, in this video I am going to talk about the laser properties and some of the challenges faced in the production of laser light. Laser properties, it is monochromatic, having a single wavelength. It is coherent, means all the light rays are in phase, and it is unidirectional, means all the light rays are moving in one particular direction, and also it is a very highly intense beam of light. The intensity of the light must be very high. So when the light has all these properties, then we can call such light as the laser light. Among this, we already saw that the coherent light is produced by a particular process that is known as the stimulated emission. Okay. Yes, now let us see how we can produce such a laser light at lab, because naturally laser light is not available. So some of the challenges faced in the production of laser light is, we know that the number of atoms in the upper energy level N2 is very less compared to the number of atoms in the lower energy level E1. So that is N2 is very less than N1. It's around 10 power 30 times less. So because of this, stimulated emission becomes a very weak process. Okay. So but we need stimulated emission for the production of laser light, and because of this the laser light production will become very weak. So emitted light will be mostly then by the process called the spontaneous emission. So it will not be by stimulated emission. So that means what the light we will get will be non-coherent and divergent light. Okay. So this is a huge challenge in the production of the laser light. And to obtain laser, therefore what we have to do is the induced absorption and spontaneous emission, these two processes, somehow we have to suppress these two processes, and the third process, that is stimulated emission, we have to make it dominant. So only when we make the stimulated emission dominant and these two processes suppressed, we will be able to produce the coherent directional light as well as a highly intense beam of light, and that is what the laser light is.